Envision looking not too far off and seeing a dawn that involves half the sky. NASA has delivered pictures of a never-before-seen peculiarity where a star named Betelgeuse went insane, off-catapulting an immense piece of its surface mass. The occasion is known as a surface mass launch, and as per the Space Organization, the discharge was 400 times the mass of a common solar flare from our Sun. Researchers describe the occasion as watching heavenly development in real time, with a star taking off such tremendous lumps of its actual structure. Shockingly, the disastrous blast of this very red monster is disturbing quite a bit of what we know about the universe. Why did Betelgeuse go insane, and how might that influence the universe? We should figure it out. Heavenly bodies are comprised of many stars and are organized according to folklore and legends. They are still used for navigation today. One such star is Betelgeuse, which is among the biggest and most brilliant stars in our night sky. The brilliant ruby-red sparkling star, known as Betelgeuse, is situated in the upper right shoulder of the winter constellation Orion the Hunter. When seen mindfully, stargazers recognize it as a fuming beast with a multi-day-long heartbeat of regular throbs. Because of its troubling orange-red tone, Betelgeuse is effortlessly recognized. It's ideal for persuading skeptics that stars do, in fact, have various tones. It is otherwise known as Alpha Orionis and is the second most brilliant star in the constellation, after the blue supergiant Rigel. Betelgeuse is a captivating object for star studies and observations, due to its variable nature as well as its odd name. Regularly, stars with the name Alpha are the most brilliant stars in their constellations, although Rigel, Orion's other brilliant star, is brighter. Betelgeuse is Alpha Orionis because of its name, brilliance, size, and ruddy tint. It is also perhaps one of the most notable stars. The fact that this star filled in as the model for both the character and the film Betelgeuse makes it significant. The star is the seventh most brilliant star visible from most of North America, Europe, and Canada, and it is the 10th most brilliant star overall in the sky. Earth is relatively close to Betelgeuse. Space experts can't pinpoint Betelgeuse's exact distance from Earth, although they believe it to be somewhere in the range of 430 and 724 light-years away. Betelgeuse is the most brilliant red supergiant star and is closest to Earth in our galaxy. There are only 200 red supergiant stars that have been identified. The Sun has a radius that is around 764 times bigger than Betelgeuse. If the star replaced our Sun in the solar system, it would reach past the asteroid belt and, indeed, even past Jupiter. This suggests that Earth, Mars, Venus, and Mercury would all be completely ingested. Betelgeuse is multiple times as massive as the Sun. This very monster has 12 to 26,000 solar radiances and is visible from 548 light-years away. This star has a surface temperature of around 3,600 Kelvin, making it cooler than the Sun. Nearly 13.3% of Betelgeuse's brilliant energy is apparent light. If human eyes could see light at all frequencies, Betelgeuse would surpass Sirius as the most brilliant star in the night sky. Betelgeuse loses around 1 solar mass every 1,500 years. The red star is surrounded by a cloud since this material is being shot out unevenly from the star every which way. A haze of material, multiple times bigger than the star, encompasses Betelgeuse. The size of this cloud is also thought to be 30 galactic units, or multiple times the solar distance. The Sun and Neptune, the farthest planet in the solar system, are separated by this distance. Our solar system's Sun constantly launches mass into space, which is known as solar flares. However, the Sun only breathes out tiny sections of its outer atmosphere, known as the corona, giving the phenomenon the name coronal mass ejection, CME. As a result, coronal mass ejections and surface mass ejections can happen at separate times. When a star discharges part of its unstable outer environment, it causes a CME, known as the corona CME. Coronal mass ejections from our solar system happen frequently and can affect Earth and its inhabitants. CMEs can travel more than 1,800 meters per second, while launching magnetic fields and plasma into space, sometimes appearing on Earth within hours. A CME can disrupt and damage Earth's satellites and power systems when it happens on the side of the Sun that faces the planet. Also, it sporadically places astronauts in orbit in danger. The new discovery sheds light on the unusual cause of Betelgeuse's changes, coming from 2019. The material that the star launched out detonated into space, cooled, and created a cloud of enormous dust that concealed Betelgeuse's brilliance from Earth-based observers. Furthermore, Betelgeuse's prestigious, consistent beating pattern has been altered. The CME on Betelgeuse is surprising since it released 400 billion times more mass than an ordinary CME, which made the star shudder like a dish of gelatin treats. According to a NASA news release, Andrea Dupree, a space expert at the Center for Astrophysics, stated that the star's internal convection cells might be in disarray while its photosphere, or star surface, struggles to reproduce itself. Cosmologists have been tracking the star's consistent pattern for the past 200 years, but it no longer exists. All red giants, including Betelgeuse, are dying, and being able to observe this process will allow specialists to gain some important insights into the development of stars. Most stars in the universe are powered by nuclear fusion, which eventually runs out and causes a star to undergo a series of fascinating heavenly changes before it ultimately dies. When a star is born, it is made of hydrogen, which under the force of gravity fuses in the star's core to make helium. In a nuclear blast, a lot of heat and light energy is regularly produced during the fusion process. This energy moves to the star's surface and is emitted as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium begins to fuse with carbon to form carbon. After the helium is spent, neon will eventually fuse with carbon to form oxygen. When this happens, the fusion of neon with oxygen absorbs energy instead of releasing it, because there is nothing to oppose the star's extremely strong gravity. When oxygen begins to fuse, the star collapses on itself, leading to a supernova explosion. A supernova, one of nature's most impressive forces, can produce more energy than 10 billion suns. Stars shift tone during the course of their existence, from the youngest, hottest blue structures to the older, cooler red varieties, depending on what phase of their heavenly development they have reached. The Greek philosopher Tmy in 168 AD peculiarly referred to Betelgeuse's color as having a bronze tint. 3 centuries ago, Chinese astronomers had described the star as having a yellow appearance, possibly implying that Betelgeuse was once a yellow supergiant. Astronomers might gain a better understanding of how red stars lose mass in their final days, prior to detonating in a bright supernova explosion from Betelgeuse's blast. As Dupree notes, we've never seen a massive mass launch on the surface of a star before. We are left with something going on that we don't completely understand. It's an entirely new phenomenon that we can observe directly and resolve surface details with Hubble. We're watching heavenly development in real time, but it's unclear whether this development predicts Betelgeuse's impending supernova explosion, as the results are so surprising. NASA issues a warning that Betelgeuse might not have reached the end of its life, even though it is approaching the end. Vast time is long, and red supergiants die quickly by comparison. According to NASA, Betelgeuse will explode in the next 100,000 years. Betelgeuse has been the subject of significant study since the 1st century BC. More recently, a researcher by the name of Saran Nance and her team worked to learn the likely timing of the supernova explosions of red supergiants like Betelgeuse, to figure out how a star that massive would behave over time. Nance and her team ran various simulations involving Betelgeuse as a model, and they then compared their findings to field observations. Why did Betelgeuse suddenly dim, clashing with its regular cycle when it won't likely explode for another 100,000 years? Betelgeuse was expelled from its home in the Orion-OB1 association, which includes the stars in Orion's belt, and has been seen traveling through the interstellar medium at a speed of more than 4 light-years wide. By mid-February 2020, Betelgeuse had lost 2.5 times as much brightness, dropping from magnitude 0.5 to magnitude 1.7 after starting to dim strongly in October 2019. By February 17, 2020, Betelgeuse's brightness had been stable for almost 10 days, and the star had begun to light up again. However, Betelgeuse seemed to have stopped dimming completely 5 days later, effectively ending the dimming episode. Given that there were no major changes in the infrared on February 24, 2020, it appeared that the new visual fading was largely inconsequential. A study concluded that the star's dimming was likely caused by a cloud of massive grain circumstellar dust. Absorption was ruled out from having a major impact in a study using measurements at submillimeter frequencies, but the dimming appears to be caused by large star spots. Further investigation showed a dramatic rise in Betelgeuse's brightness between May and August. Betelgeuse is so close to the Sun that it is extremely difficult to see from Earth. Before 2020, when Betelgeuse was related to the Sun, it was also 0.4 in brightness according to observations made with the Sounder satellite. In June and July of 2020, the star had faded by 0.5 since its previous ground-based observation in April. Everyone was shocked by this, because the maximum and resulting minimum were expected to happen in August and September 2020, and around April 2021, respectively. Betelgeuse's brightness was known to fluctuate widely, making predictions difficult. The dimming seemed to indicate that a second dimming event might occur much earlier than expected. The discovery of a second dust cloud coming from Betelgeuse, which was linked in June 2020, suggested that a cool patch on its photosphere might be the cause of the dust. In August, a second independent analysis confirmed the initial speculation. The dust is thought to have been created by the gas the star had expelled, according to studies done in 2022 using the Hubble Space Telescope. A dust storm might have been created by a surface mass ejection. The material was shot out from the star's surface thousands of kilometers away, where it cooled, compacted, and formed the star's dimming dust. The damaged photosphere, which was about 3 times as massive as our moon, traveled into space, cooled, and formed a dust cloud that covered the star from the perspective of observers on Earth. The dimming, which began in late 2019 and lasted for a few months, was clearly perceptible even by casual observers who noticed the star's brightness change. More surprising, the 400-day pulse rate of the supergiant has disappeared since around 200 years ago. Astronomers have been tracking this cycle by analyzing changes in Betelgeuse's surface movements and brightness variations. Its disruption reveals the magnitude of the impact. Cosmologists have now developed a likely hypothesis to explain the disturbance. The star is also slowly but clearly rebuilding strength, and the photosphere is recovering. The star's normal cycle is being lost, and the interior is vibrating like a bell that has been struck. A massive stellar surface mass ejection has never been seen before. There is still something going on that we don't fully understand. We may directly observe this entirely new phenomenon and use Hubble to observe surface features. Real-time observation of stellar evolution. When will it happen? Probably not in our lifetimes, but no one truly knows. Could be, in fact, tomorrow or a million years from now. Will Earth be annihilated by Betelgeuse's supernova explosion? No, the blast of Betelgeuse won't affect or destroy life on Earth, since it will happen far too far away for it to impact the world. Cosmologists estimate that for a supernova to be hazardous to humans, we would need to be within 50 light-years. Also, Betelgeuse is more than 10 times further away. Instead, everyone on Earth will be treated to an extraordinarily stunning view of a very bright star in the evening sky. Finally, due to Betelgeuse's location, astronomers will be able to study the star when it undergoes a supernova explosion. Betelgeuse isn't currently visible in the night sky, so don't go searching for it. Even if it exploded right now, we wouldn't see much of it. However, it is in the afternoon sky during August. Betelgeuse could have already gone supernova. Betelgeuse, or Scarab Juice, is not just a significant star in the Orion constellation, but also plays an essential role in the study of stellar evolution. Its size and unique characteristics make it an excellent laboratory for understanding the life cycles of massive stars. The star is classified as a red supergiant, a category that includes some of the largest and most brilliant stars in the universe. Observations suggest that Betelgeuse may eventually undergo a significant change, leading to a magnificent supernova event. This explosion is predicted to produce a neutron star or possibly even a black hole, depending on the remaining mass after the blast. Experts are eager to gather more data about its behavior, particularly in relation to mass loss rates and surface changes, which can provide insights into similar stars across the universe. In addition to its scientific importance, Betelgeuse has also captured the public imagination. Cultural references, such as the classic 1988 film named after the star, have cemented its place in popular culture. As it moves toward the end of its life cycle, interest surrounding Betelgeuse continues to grow, highlighting its significance both scientifically and creatively.